Look at it. It defies gravity, logic, and 1,000 years of weather. It was built without a single engine, without a computer, without even the wheelbarrow.
Yet, to recreate this today would demand an investment of over $10 billion.
This is more than stone and mortar. This is a story of human will against nature itself.
This is the Babylon Hanging Gardens water system. The riddle of the gardens has always been, not how did they build the stone, but how did they build the water?
How do you lift the weight of a river hundreds of feet into the blazing sky and keep it running non-stop?
To find the answer, we must first travel back to the world that demanded this impossible feat.
To understand the structure, we must first understand the man who commanded it, King Nebuchadnezzar II.
He sat atop an empire defined by conquest, expansion, and the absolute need for visual dominance.
This was an age of unprecedented political power, but also one of deep cultural tension.
His queen, Amytis, was said to long for the mountainous, green landscape of her Median homeland.
The Hanging Gardens were not a pleasure garden. They were a spectacular, political reassurance.
This project was not a convenience. It was an absolute necessity to secure the unity of his empire and his place with the gods.
It was a project of faith, designed to bring the fertility of the gods into the heart of the capital. The stakes were the reputation of the king and the future legitimacy of his dynasty. To begin the build, they first had to face the most formidable enemy, the land itself. The location itself was the first, and perhaps most formidable, enemy.
The site was chosen despite the logistical challenges, not because of convenience. It offered zero natural elevation.
At its peak, the structure may have spanned 400 feet wide and reached over 80 feet in height.
Every single element had to be engineered to overcome the two climate challenges, punishing heat and catastrophic seasonal flooding. This climate demanded non-traditional materials. The humidity and the water itself would destroy simple sun-dried bricks.
The physical dimensions meant a crushing volume of materials needed to be moved across the desert every single day.
The seasonal floods of the Euphrates River were the ultimate deadline. Any delay meant the river would wash away months of work. This necessity forced the builders to engineer for permanence, using costly and time-consuming fired bricks and waterproof asphalt.
The construction had to be more than a building. It had to be a fortress against the very elements surrounding it. This massive foundation was their first line of defense. But the real genius was hidden within the blueprints themselves.
They had no CAD software, no stress analysis. Yet the plans they followed understood physics better than many modern engineers.
The secret wasn't just brute force, it was hidden logic. Every block, every arch was a precise calculation.
Beneath the visible surfaces, they used the fundamental strength of the Corbel Arch, a structural whisper telling us their genius. This technique allowed them to span wider distances without using timber, which was scarce and prone to rot.
Blocks were not just stacked, they were often interlocked, a design feature that provided seismic joints against tremors.
Perhaps the greatest hidden feature was the water drainage. The structure needed to manage rainfall and irrigation overflow.
A system of sealed, tiered terracotta pipes carried thousands of gallons of runoff per day, preventing saturation and collapse. Each joint had to be sealed with a mixture of bitumen and lime mortar, the ancient equivalent of waterproof sealant.
For the planting beds to function, they required 3 perfect layers: a base, a waterproof membrane, and deep soil.
The second layer was often a dense reed mat, saturated with bitumen, designed to hold the soil and further prevent drainage erosion.
The soil itself had to be a rich loam, deep enough to support large trees, which meant hauling unimaginable quantities to height.
Modern engineers calculate the load on these terraces to be equivalent to 4 fully loaded 747 jets per terrace section.
This ancient structural blueprint tells us they were calculating not for years, but for centuries of service.
The exterior was designed for glory. The interior was designed for survival against water, weight, and time. But before any of this structural work could be finished, the mountain had to move.
The logistical nightmare of material sourcing was about to begin.
Before the walls could rise, the mountain had to move. The raw materials, limestone and gypsum, were sourced over 50 miles away. Quarrying was a brutal art, using the expansion power of water-soaked wood wedges to split massive blocks from the quarry face.
This technique allowed them to free blocks weighing up to 5 tons, the size of a modern car.
The blocks were then dressed by skilled masons at the site to reduce weight and simplify transport.
And then came the transport. Without the wheel on this terrain, without the engine, how do you move a stone this size?
This wasn't construction. It was an exercise in industrial-scale human logistics, relying on simple rollers and sheer manpower.
The scale of the project was a constant, grueling test of human endurance under the sun.
For the heaviest materials, the river provided the only viable highway, ferrying them via massive wooden rafts. This method introduced new challenges, managing the currents and navigating the shifting sandbanks.
Once at the river's edge, the materials still needed to be lifted, a difficult and dangerous transfer from boat to land.
A momentary lapse in coordination meant the loss of material, and often the loss of life.
The entire material flow was a highly complex and coordinated logistical dance.
To reach the upper levels, the materials were transported via a massive, ever-increasing earthen construction ramp. The most common building block was the sun-dried mud brick, essential for the sheer volume of internal fill required. The clay was mixed with reed and straw to increase its tensile strength and prevent cracking during the drying process. Only after the perfect mix was achieved could the mud be pressed into simple wooden molds for uniformity. For the exterior and the crucial water system, a far superior fired brick was required, a process that demanded.
These glazed, fired bricks were the only material capable of resisting the constant moisture from the water channels.
The logistic team had to ensure a steady supply of both sun-dried and high-quality fired bricks reached the masons. The mortar, too, needed to be constantly delivered in the correct quantity to every corner of the site.
This logistical leap proved that the ancient Babylonians operated at a scale we today call industrial.
But all this planning meant nothing without the force that held the project together. Human bodies.
This mega project was not built by blueprints. It was built by bodies.
Pull the rope! Heave the stone! Pull the rope! Heave the stone!
Every level gained was a fight against exhaustion and gravity, reliant on simple but perfectly executed knots and rigging.
Working without safety nets, a single misplaced step was often fatal. The human cost was immense.
The skilled masons were the architects of the final form, ensuring the integrity of the crucial water channels. The techniques were simple: ramps, ropes, and the block and tackle, but the commitment was profound.
1 and 2 and 3, pull now! 1 and 3, pull now!
Internal volumes were rapidly filled with mud brick, saving the expensive fired stone for the waterproof exterior and key structural elements.
The focus now shifts from static structure to dynamic mechanics. The massive water lifting system.
Secure that brace tightly, men. We cannot afford any weakness in the main axle. Drive that tenon home.
This monumental component was too large to build in place. It was assembled nearby and then lowered into its working well.
Perfect vertical alignment was non-negotiable. Any imbalance would destroy the wooden bearings within days.
The water journey begins at the Euphrates, controlled by massive stone-cut sluice gates. Initial filtering was essential. The muddy river water contained sediment that would quickly grind the wooden parts to dust.
The first water wheel begins its endless task. A simple, repetitive lift to the first tier of the gardens. Each scoop delivered a precise volume, ensuring the channels carried a steady, predictable flow.
The system was now functional, but only for the first 2 levels. The challenge was the second, even greater lift. For the maximum height, a more complex, continuous lifting mechanism was required, the Archimedes Screw. Driven by oxen or human labor, the screw could provide the continuous, high-volume lift that the water wheels could not.
The power source was purely biological, the coordinated effort of many men, or the silent, endless pulling of beasts.
Finally, the water reached the peak of the structure, defying gravity for the final and most glorious time.
The logistical and mechanical challenge was solved. Now, the completed structure could fulfill its final, intended purpose.
The king's vision of a green mountain in the desert was now a reality.
The original purpose was clear: to glorify the God King and create a timeless symbol of his power.
It was a political move designed to reassure a foreign queen and unify a diverse empire.
The immediate political and military outcome was a consolidation of power through sheer, awe-inspiring display.
It worked. It instantly became one of the greatest man-made structures of the ancient world.
However, its truest impact was cultural. The physical empire eventually crumbled, but the legend endured.
The ingenuity of the structure changed the definition of architecture and engineering forever. The tiered garden concept itself was copied and revered across the entire ancient world. Maintenance was the garden's ultimate vulnerability. The water system required continuous, dedicated labor and fuel.
When the political will, or the labor, inevitably disappeared, what remains is a testament to an impossible vision that outlasted the empire itself.
Enjoying the journey? Don't forget to like and subscribe.
But centuries later, this structure still guards its greatest secrets.
The greatest puzzle remains unsolved. The precision of the original masonry still baffles historians.
The question is not just how they cut the stone, but how they maintained such consistent quality across a 10-year project.
The engineering feat was extreme. Even with a theoretical Archimedes screw, the friction and force required for that height is staggering.
Did they use multiple, staged lifts, or a single, massive, continuous spiral? We simply don't know the full mechanism.
Another mystery, the mortar. Some surviving sections contain an unknown white mortar, far stronger than typical Babylonian asphalt.
Could they have discovered a precursor to Roman pozzolana cement over 1,000 years before the Romans?
What other materials were imported? Historical records mention cedar, juniper, and exotic woods.
The mechanical details of the highest lifts remain purely theoretical, based only on fragments of carved timber.
Was the entire structure also an astronomical calendar?
The alignment with the summer solstice is too precise to be coincidence.
The Furses. The Babylonians were master astronomers, and it is highly likely the structure served a dual purpose.
We can rebuild it with our modern tools, but we still cannot fully decode the methods of their minds.
What other secrets are locked in this stone? Secrets that only the original builders ever knew.
The Babylon Hanging Gardens water system remains an enigma, the ultimate manufacturing mystery of the ancient world.
If ancient civilizations could achieve a project of this magnitude without so much as a steam engine,
imagine what we are truly capable of. What historical mega project should we decode next?
Comment below with your suggestion.
And if you want to see more stories of impossible engineering,
subscribe now to join the factory.